Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to determine the x-intercepts of functions and determine the multiplicity of the roots of a function. How are we learning it? Through the zeros notes and the zeros assignment. When can we use this information? To examine financial trends in a business and determine when the value might reach zero and the business goes into debt. How do you know you learned it? By getting a score of 4 on the zeros assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffles. After that, we'll go over the zeros notes, and then I'll give you time to complete the zeros assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the zeros notes. The notes begin with the learning goals and success criteria. First, what is a zero or an x-intercept? The x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So if we look at this, we have a line here and it crosses right there. So in this case, we would say that our x-intercept is at about 2. And we also call these x-intercepts zeros or roots. So they're called all of these different things. So how do we determine where an x-intercept exists? X-intercepts occur when y equals 0 and x is not undefined. So for instance, if I have y equals x minus 1, well, I just want to plug in 0 for y and solve for x. So I plug in 0. Now I'll add 1 to both sides, and I get that x equals 1. So that is the point where my x-intercept occurs. So if we put it into coordinate form, it would occur at 1, 0. Now what is multiplicity? Multiplicity is the number of roots a polynomial function has at the same x-intercept. So multiplicity occurs when there is more than one root at the same x-intercept. So an example of this would be x minus 1 squared. Well, we should notice that x minus 1 squared is the same thing as x minus 1 times x minus 1. So we can solve this because we just need to set it equal to 0. So both of them would have to be 0 because they're the same. So we'd add 1 to both sides and we get x equals 1. So that would be our root. X equals 1, but it's occurring twice because we still have both of these here. So we would say that my x-intercept is at x equals 1 and has a multiplicity of 2. So how does this help us, knowing the multiplicity? Well, the multiplicity can determine whether the graph will cross the x-axis at the x-intercept or just touch it. If the multiplicity of the function is even at the x-intercept, so it has a x squared, x to the 4th, x to the 6th, etc., it will touch the x-axis but not cross. If the multiplicity is odd at the x-intercept, it will pass through the x-axis. So even multiplicity. So notice here we have a point here, and it has a multiplicity of 2 or 4 or something like that. It's going to touch, bounce back, and come back up. So anytime we have a multiplicity that's even, it's going to touch at that point and then bounce back up. Now, an odd multiplicity is going to pass through. So we have a x-intercept here or a 0 here at -2, and it's going to pass through and keep going. So even multiplicity, odd multiplicity. There's a video here now that shows you how to graph functions in Desmos. So you can go ahead and watch that video. Let's take a look now at how we can use Desmos to graph any function. So in order to do that, we're going to go to desmos.com and go to Graphing Calculator. And here we can type in an equation. So let's say that we have a linear function, which is y equals 2x minus 5. And notice it graphs it for us. It creates this graph here. We can type in any kind of function. We can do an exponential. Y equals 2 to the x power minus 5. That's what it would look like there. We can type in a quadratic, y equals 2x squared minus 5. And see exactly what that one looks like. we can do trig functions. So y equals sine of 2x. And that's what it would look like. We could do logs. Y equals log 2x. And see exactly what it looks like. So we can graph any one of these kinds of functions and it will do it for us in Desmos. If there's ever any difficulties with what you're trying to do, so let's say I'm trying to do a squared term, so y equals x squared, and you're not sure how to do that, this little keypad here will click out, and now I can change it to be squared. I can change it to be any exponent here, so I can click on this and make it to the 6th power or whatever I want it to be. So you can use this any way you want, and this is how we can use Desmos to graph any function. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the zeros assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The assignment begins with the learning goals and success criteria. We'll go ahead and click Next. Now, here it asks, what are the x-intercepts and what is the multiplicity at that x-intercept? So to find the x-intercept, that means y is equal to 0. So if we make this 0 and then solve, we'd have to add 1 to both sides, and we get x is equal to 1. So the x-intercept is at x equals 1. So that would be our x-intercept. And what is the multiplicity? Well, we can see this has an exponent, an imaginary exponent of 1. So the multiplicity is 1. Now let's look at this one. We have x minus 1 to the 4th power. Well, we can see that the multiplicity is going to be 4 because there's an exponent of 4 here. And then, same thing, if we take 1 and subtract 1, so 1 minus 1 is equal to 0, which is what we would need y to be. So we could say the x-intercept is at x equals 1. And we would do that for each of these. Now, the x-intercept should not change for any of these, but the multiplicity should. And then we'll go ahead and click Next. Now, it says, which of the following functions will cross the y-axis? And remember, it's all the ones with the multiplicity that are odd. So each of these should be it. And we can check our work by graphing them. So we type in y equals x minus 1. And notice that one crosses. Then we do the same thing. So y equals x minus 1 to the 3rd power. And notice that one crosses as well. So you'll type in each of those that you selected. And then click Next. It says which ones are going to touch but not cross. Well, we know that's the ones with all the even multiplicities. So this one, and this one. And again, we'll check our work by typing them in. So y equals x minus 1 squared. And we can see that that one touches and comes back. So you'll type each of these in and check your work. Then we'll click Next. Then we're given these functions where we're multiplying multiple parts together. So what is the x-intercept here? Well, the first one is -3, and the multiplicity is 1. And the second one has an x-intercept at 1, right? Because 1 minus 1 is 0. And then a multiplicity of 2. So you'll just fill in this table here, just like I did there, and then click Next. Now it says, without graphing, state the x-intercepts of each function and state what happens to the graphs near the x-intercepts. Meaning, is it going to touch or cross? Well, here we can see that we need to set this up and solve. So we add 3 to both sides, and we get 2x is equal to 3, divide by 2, and we get x is equal to 3 over 2. So x equals 3 over 2 is my x-intercept. And my multiplicity is 6. So is it going to cross or touch? Well, it's an even multiplicity, so it should touch and not cross. So you'll do that for each of these. Now, for these ones, you're going to decide, does it cross or touch for each part? So the first x-intercept, the second x-intercept, first multiplicity, second multiplicity. So here we can say that the first one is going to touch because it's got a multiplicity of 4. So first touches. And then the second one has a multiplicity of 1, so it's going to cross. So second crosses. So we select those two. And we'll do that for each of these. And then click Next. Now for each of these ones, we're going to click Graph It and then discuss how they are alike. So we have x minus 3 squared and 3 minus x squared. So I hit Graph It. And notice they're the exact same. So you're going to go ahead and state how they're the same and how they're different. And then try to explain why that happened. Same thing here. We have these two. We hit Graph It. Again, exactly the same. Now, for this one, for instance, though, x plus 3 cubed and 3x plus 3 cubed, we hit Graph It. Same. Here now, these ones are different, though. So you're going to state how they're different and then why you think they're different. So you'll go ahead and do that for each of these. And then at the end now, we're going to graph a function. And we're just going to sketch a graph. It doesn't have to be perfect. It says that we're going to sketch a graph with multiplicity of 2 at x equals 1. So I'm going to go here to x equals 1. I'm just going to put a dot there because I know that's going to be an x-intercept. And then a root of multiplicity 3 at x equals negative 2. So there's going to be one here at negative 2 as well. So those are my two x-intercepts. And the first one here at x equals 1 has a multiplicity of 2, which means it's going to bounce. It's not going to cross. So it's going to come here and touch and then come back. Then when it goes through at x equals negative 2, it has a multiplicity of 3. So it is going to cross. So it's going to pass through here just like that. So that would be one example. And there's no right or wrong way. You could have this go way up and come back down, whatever you want to do, as long as it touches here and crosses here. I could also do it like this. Instead of having it come from positive to negative, I could always come from down here. So it could go like this, touch, come down, and go back up and through. So that would be another example. So once you're done with this activity, we'll go ahead and go back to our Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.